So guys, we're going to work on the problems and we're going to build on what we did today. Let me see. Let me try this one. Number 27. What does this say? Okay. Remember guys, when you take a function and you multiply it by 2, it's going to be a vertical stretch by a factor of 2. What is vertical stretch, guys? Everything on the x-axis will be there, but everything above the x-axis will be stretched out. So we are going to draw this. How exciting. Now I have to change something, guys. Okay, my bad. Let me go back. Anyway, I'm not going to worry about it. I don't like this hand, but it has to be some kind of glitch, but we'll deal with it. All right, guys. So we were working on number 27. Okay, we're going to circle 27. I know you probably, if you can't see, you have to tell me. Okay, based on what we studied today, this will be a vertical stretch by a factor of 2 because I'm multiplying the whole function by 2. I'm going to write it down here. Vertical stretch by a factor of 2. Okay, that's kind of important. It comes from your notes. It could come from here, right here, the notes. Okay, so what does that mean, guys? That means I'm going to take these points. Okay, this one will be where it is. It's on the x-axis. This one will be where it is. This one will be where it is. Okay, it's important. This one will be twice as high. If this is 2 boxes, it's going to be here. And this one will be twice as low. If this is 2 boxes, that's going to go here. Okay. Anything on the x-axis, this is vertical. Vertical means moving away from x-axis or moving closer to x-axis. Everything on the x-axis will stay intact. So all you have to do is, guys, connect them. Well, let's do this black. This stays here. This stays here. This stays here. And these black dots, they are vertical stretch. So they're going to be twice as high. Now let's use a red. Let's use red. That's the graph, guys. How nice.
So quick question. How are we going to be answering these on the exam?
Good question. Just a moment. Let me fix this. I made a tiny error. It should be here twice, right? That's way too low. So that's much better. Okay, very good question. So guys, I am going to give you this as a multiple choice question. I will say, I will draw the pink one, the correct one. Then I'm going to draw 3 wrong ones and you have to choose the right one. Does that make sense?
Oh, okay. So you'll have like the blue line and we have the vertical stretch of that line.
Right. The blue line will be a part of your question. I can say, here is my f of x. Okay. Now, which one below represents y is equal to 2 times f of x? Okay. I'm going to draw one red, which is the right one. Now, of course, I'll draw all separate pictures, and that's going to be a lot of extra work for me, but that's not something you worry about. I'll draw another one like this. Sorry. I'll draw another one like this. That's a vertical stretch, true, but not by a factor of 2. So the green one is wrong. It's probably more like by a factor of 3. So don't worry too much about it. We will do more problems. I know it's a little hard to assess because it's all done by hand, but this one can be given. as a multiple choice question. Okay. Does that make sense?
Yes, that does.
Okay. All right, guys. So let me try one more. Don't panic too much because there will be some questions I will say, this is perfect for our exam. Okay, we'll do more. We are not done. So guys, let's try this one. Now you have to practice these. Okay, this one I'm going to say, I'm going to do G28. Okay, it's actually fairly easy. Now I do know dividing by 2 means multiplying by half, and it means a vertical shrinkage by a factor of 2. Okay, vertical shrinkage, shrink. Do they say shrinkage, shrink? Let me see what they say. Shrinking, vertical shrink. Shrink sounds like a psychiatrist, so I don't want to use the word shrink. Okay, let's call it vertical shrinkage. 28 is vertical shrinkage. I'm writing here. Now I could, just to let you know, I could tell you to define in English what this does. Okay, I could, instead of asking you to graph, I could say write in English what this will do. You would say it will be a vertical shrink or shrinkage by a factor of 2. And you have to tell me 2. If you just say vertical shrinkage, you will get half the points. So I can give you these problems and choose the right picture. That'll be multiple choice. Or I can ask you to just tell me in English, which will be an easier version of the same problem. Okay, so guys, let's draw it. So this will be a vertical shrinkage. Vertical means up and down, everything will move. Shrinkage means everything will get closer to the x-axis, except for the guys that are on the x-axis. So who are on the x-axis? Let's draw them. This guy is not going to go anywhere. This guy is not going to go anywhere. This guy's not going to go anywhere. This guy will be half. Factor of 2 means you divide by 2. Doesn't matter how you say it. And the graph will look like somewhat like this. See, it seems like they're taking the blue curve and pushing it towards the x-axis. Okay. Let's try. I'm going to skip 29. You should try it. What is f of half of x? Let's try 30. Okay, let's try number 30. First, I have to decide what it is that's going to happen. Okay. Okay, so I'm trying number 30. It's inside, it's x over 2. Okay, we know when something happens inside, it's horizontal. When you divide it by 2, it's going to be a horizontal stretch. Okay, I know it's counterintuitive. When things happen inside, it's the opposite. That's how I keep it straight. Another good news, if you kind of forget, you can just draw a graph on Desmos and see what it does. It'll do the same thing. You don't have to draw the exact same graph. You won't be able to. So I'm going to write down number 30's English interpretation. This will be a horizontal something. Horizontal something, and divided by 2 is a stretch, not a shrinkage stretch. And by a factor of 2. Okay, what does that mean, guys? Back to the old stuff we were doing. Everything on the y-axis stays where it is, okay? Everything that's not on the y-axis is moved horizontal stretch, moved away by a factor of 2. What was that supposed to mean? This is going to go here. This is 1, 2, 3, 4. Unfortunately, this is going to go here, way out. This will go twice. And this will go 1, 2, 3, 4, 8. So it's going to look like this. Everything on the y-axis will be fine. And this is known as a horizontal stretch. It pushes everything away from the y-axis. Everything on the y-axis stays where it is. And there's only one point in this picture. So I'm going to pause here a little bit, guys.
You leave it there for a little bit.
Of course, of course.
Thank you, sir. I got it.
Okay, awesome. So guys, the next two are the hardest, okay? And I'm gonna do one of them for you, okay? The reason this is hard, I'm gonna do it step by step. And in order to do that, I'm gonna do a little, I'll tell you what I'm doing. I'm gonna write down this first here. I'm doing 31. I'm gonna write down, I need a big picture and you're gonna see why. And be a little patient, okay? I'm gonna spend a little bit of time on this. 2f of x plus 2. It's they're combining everything here. And this somehow is giving me typo, and that's fine. I'm going to ignore it, but I think my question is correct. Okay, I'm writing 31. Or why don't I do that? I don't like this type of thing. So guys, let me erase this. Give me 1 second. Okay. I'm going to take my curve. I need the room as follows. Okay, I'm working on the last problem, second last, and which goes, I'm going to just cut this out because I need the room. Okay, be a little patient. Okay, this is a little hard. Okay, they're doing a lot of things in the same problem. What's that supposed to mean? They're going inside, adding a 2, and that will, remember from yesterday, that will move the curve, whatever this is, 2 units to the left. Then they're multiplying it by 2, and you're going to act like remember, please excuse my dear Aunt Sally, you're going to start with Princess, then you're going to multiply it by 2, then you're going to add 1. So you're going to do it in this order. And how we're going to do it, we're going to do it in 3 stages. Okay, so I'm going to first do this one. And then when you add +1, you're going to move everything up 1 unit. Okay, so it involves 3 different transformations, and it's hard. So first, I'm going to do x plus 2, and let's do it in pink. So just to let you know, give me 1 second. Something is acting a little funny, but we'll get it. So guys, I am trying. This blue function is f of x. I'm going to first do +2. +2 means it moves 2 units to the left. So this will go here. This will go here. This will go here. This will go here. And this will go here. And let's do it nicely. I just did the first one. Okay. Now, what I have pictured, my red thing says, my red graph is the graph of this. Now, when I multiply it by 2, it's a vertical stretch by a factor of 2. I'm going to do it in green, okay? But it's 2 times f of x plus 2. Well, vertical stretch of a factor of 2. You're going to work on the red one. You don't need the blue one anymore, okay? Vertical, remember, multiplying any function by 2 means vertical stretch by a factor of 2. So if this is 2, this is going to go 4. anything on the curve will be there. This will be there. That's not bad. This will go here. Everything on the x-axis will remain where they are. If it's a horizontal thing, everything on the y-axis will remain where they are. Now it's not that bad. Okay, so I've done the green one. Now the last one isn't that bad. I'm going to use yellow, I guess. The last one is to the green one, whatever your green function is, take that and add 1 to it. Well, when you add 1 to it, you move everything 1 unit up, everything, okay? And I'm going to do, as promised, I'm doing it yellow. This point will go here. 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 And this point will go here. And let's draw a nice curve. I know it's a little difficult, but I know it's not beyond you guys. So my yellow answer is my final answer after I have applied 3 distinct transformations to the blue curve. And there's no other way. You have to do it one at a time. I can do it all 3 at the same time for each point, but it's not something I'm going to suggest if this is your first time doing it.
So I have a quick question.
Mhm.
So for the red one, we just move it over 2.
Correct. 2 units to the left. Yeah. Mhm. 2
And
units.
how do we know that it goes to the left? Because
Sure,
plus
sure. Let's go over it. So last class, we learned if I replace x with x plus 2, it goes 2 units to the left. If I replace x with x minus 2, it goes 2 units to the right. Okay. If I replace x with x minus 3, it goes 3 units to the right. If I replace in my function x with x plus 3, it goes 3 units to the left. So let me show you where it is in the notes. Right here. Okay. Plus c, c is 2, 3, 4. It's going left. And it's going to be the same for minus c. They say it a little funny. They're calling it c. If it's minus c, they're calling it right. If it's plus c, they're calling it left. Does that make any sense?
yes.
Good. So these are the transformations we did yesterday. And today we did just 2, vertical and horizontal shrinking and stretching. And there are really 4 of them here. So it's a little, generally these 2 are harder. And here's the summary of all. And the best way to learn is do some of the MATLAB problems, do some of the ones I have assigned, and you're going to see, oh, okay, that's what he was talking about. And take a look at the video, come and talk to me. Not a problem, but this is a little challenging. I know that. Very aware of it. Okay. Any other questions, guys? Let's see what else is going on here. Okay, we did this chunk. Let's try this. I don't think this is going to be that difficult. I didn't give you a whole lot. I'm going to do a couple. I'm going to explain to you guys how to do them. Now, well, let me save this. I know somebody might ask me. Just don't want to lose that. That's a very messy work. Messy means it takes a long time to do it. Okay, very carefully. We can just do it orally. I will show some of the pictures. So this is one of your next sets. Let me see which one I assigned. I assigned 63 through 66. Okay, 60 through. So maybe the last 4. Well, let's do a few more. Okay. So guys, begin by graphing the standard quadratic function. This we will do it. And then do the transformation. Use the transformation of this graph to graph this. Not a big deal. Not a big deal. So first I'm going to draw a graph. It's something we have been doing really. So I'm going to first, it's already here, right? Now I'm going to graph. I'm going to do some of the easy ones I didn't assign, x squared minus 2. Okay. Now I'm going to write x squared, the whole function, minus 2. And we know this is going to be pushing the curve 2 units down. It's called a shift, a vertical shift 2 units down. Here it is. Okay, This one will be a vertical shift 1 unit down. Very easy to do. Take a look. It's only 1 unit down. One unit down. They're taking the red curve and pushing it 1 unit down throughout. So it's not the worst that can happen. Again, let's see what they're saying. Use the transformation. So let's try 66. Okay. It's a little hard. Let me go here. 66. Okay. Well, let's try this. What this would do, we're going to start with x plus 1. Okay. It's really like instead of this, you're writing x plus 1. So this will have an effect of I'm going to show you one by one. Okay. -2. Okay. So I'm going to first do this one. When I do x plus 1 square, I'm really replacing x with, I don't need this. It's just a distraction right now. X square, x plus 1 square. I'm moving it 1 unit left like we predicted, right? Now I'm going to do the next one. I'm going to use the same blue function, okay? Bit by bit, so that you can see the steps. Okay, then I'm going to multiply it by 2. Okay, when you multiply a whole function by a minus sign, it's going to be a reflection with regard to the x-axis. So I'm going to do this later. I'm going to pretend it's +2. Okay, for now. I'm going to do it, but I'm going to right now do +2. What happens, guys, if I do it with +2? I'm going to predict first. This is going to have a vertical stretch of the blue function. Only the blue one. The red one won't be affected. Take a look. It's a vertical stretch. Again, vertical stretch means somebody is pushing it up. And it's exactly by a factor of 2. Now I can do a next curve. If I do the next curve, it's going to be too messy. So now we have taken care of 2 steps. What's the next one? I'm going to, of course, remember we had a minus. We had a minus. When I do minus, it's going to be a vertical reflection. Focus on the blue curve. If I stick a minus, the blue curve will be flipped about the x-axis. All the transformations we learned so far, here we are. Okay, hang on to the blue curve. What happens when I add 1? When you add 1, the blue curve will be shifting 1 unit up. When you add 1 to the whole thing, that's your blue curve, will be shifting 1 unit up right here. See where it is? +1. So again, I want to ask you to draw, but I will give you a picture. I'm going to give you a bunch of pictures. I'm going to say which one is the correct one. That's how I'll give you. So you have to know it anyway. You don't have to draw it. You have to know it. And I will be, if they use x squared, x cubed, I'll be close to the functions we talked about. So that was that. If you don't understand the basics, you'll have a little. Go ahead. Go ahead.
If I get this right, we moved it over 1 first.
Mm-hmm.
And then we flipped it upside down, moved it down 2.
Firstly, you're probably somewhat accurate, but let me show you all the steps. How's that? So all the steps will be shown now. So first we said, x plus 1. Let's go back to the question. We're doing this one. I'm going to first do x plus 1. You do parentheses first. X plus 1. X plus 1. And what do we expect? We expect it to go 1 unit to the left. Remember, +1 inside the function will push it 1 unit to the left. -1 inside the function will push it 1 unit to the right. But we are sticking to the problem. Okay, hang on to this. Okay, now I'm going to do h of x. What's the next one? The next one, according to our question, is 2. Okay, you multiply the whole function by 2, what happens? When you multiply the whole previous function by 2, you can write g of x, but I'm going to be old-fashioned. I'm going to write this. So when you multiply, now I'm going to change the color to, let's see what color we can change. Let's make it orange. Look at the orange one. Compare the orange one to the blue one. According to our rule, it should be a vertical stretch by a factor of 2, and that's exactly what it is. Orange one is a vertical stretch of the blue one. Does that make any sense?
Yes.
Good. Now we're going to stick a minus sign. So I'm going to go back here. I'm going to call this next function kx. What is kx? The same as h of x, but with a minus sign. And when you do something with a minus sign, you flip it about the x-axis. When you multiply the whole function by a minus sign, look at now, compare the green one to the orange one. They are exactly the same. The orange one is above the x-axis, and the green one is below the x-axis. It's a reflection. It's called a horizontal reflection. We're almost done. Now I'm going to go KLM. Let's call this M. And it's basically the function K. It's the function K plus 1, I think. I'm going to go back and check though, but don't want to. It's plus 1. So plus 1. Now compare. Okay. Compare the purple one. Okay, the final one with the green one. All it is doing is pushing the green one 2 units up. Now you have all the functions here. All the functions that you need to show each stage. Take a look. Let me save it. And it's a little hard on day one to keep all those things straight, because when you practice, you will understand which one moves left and right, which one moves up and down, which one is a vertical shrink, which one is a vertical stretch, all those things, but you have to keep them straight.
So then we have to,
I'm
when we're doing the problems for like the test or in my math lab, do we have to go through each one, or will it be just at the end, we want the end result one?
On the MATLAB?
Like putting in the
On MATLAB?
answers, yes.
That's okay. I think I made your questions several days ago. I think they will want the final answer. They will ask you to choose. I think mostly the ones I assigned are multiple choice. They'll ask you to choose the right one. So you have to go through the stages on Desmos, ideally Desmos. It's far better than your calculator, and pick the right answer. Okay. Now, if you run into a problem that's hard to enter on MATLAB, you can tell me, I can kind of pull it out. I don't think I put a lot of the problems where you have to, try different things. I made it a little simple on you guys. Does that answer your question?
Yes, it does. Thank you.
I know it's a little messy, guys, okay? Every year we do it and people find it difficult because it is difficult. Now, if you run into MATLAB issues, I can pull some of those problems out. You can email me to my Awares, not the one on BlazeView. I don't check it every day. Just tell me number 5 is a little hard to enter, or they're asking me to drag this, drag that. I don't think there are some where they'll ask you to drag things. I don't think I pulled them in. I put them in. I try to assign the problems from your book, and I try to pick the problems that are aligned with these problems, the ones I am doing. Okay, let me try. It's repetitive now. I'm going to try 1 or 2 with in detail. Let's try number 94. Okay, and if they kick us out, guys, I'm going to certainly finish this problem. Okay, we have 10 more minutes. I will make sure we don't. I'll come back if they kick us out. Okay. So, and I will try not to rush. So let's do a so-called hard one. Okay, let's do 94. They're the same. They're asking us to use this function. Okay, let's do 94. I'm going to do it bit by bit, and you guys can tell me, oh yeah, that's going to happen. So I'm going to first start with, I'm going to get rid of all this. First, I'm going to take my absolute value function. And that's what it looks like. It looks like a V, letter V. And what am I supposed to do? I'm going to replace it with x plus 3, and I'm going to tell you what it will do. Okay, replacing x with x plus 3, I'm going to call it g of x. Again, I'm interested in the final answer, but I'm showing you all the steps so that you understand what's going on. X plus 3 will move the original v 3 units to the left, not right. And that's exactly what it did. And I'm not too surprised. Good sign. 3 units to the plus 3 will be left. 3 units to the left. Everything is pushed 3 units to the left. Good sign. Then what happens? Then I go to my problem. Okay, then I'm going to multiply it by minus 2. First, I'm going to multiply it by plus 2. Plus 2 will be a vertical stretch by a factor of 2. I can almost draw it for you guys. It will look more like this. It will look more like this, half one. I'm going to draw it for you and I'm going to test. Okay, this black curve will kind of match the blue curve, and it's not going to be perfect. A pink curve, h of x 2 times x plus 3. Not bad, right? Okay, so I'm going to change this color to purple. Just be different. Now I'm going to erase my drawing. Okay, now I'm going to in my problem, it's not plus 2, it's minus 2. So I'm going to go k minus 2. And this will be a vertical reflection, with regard to the x-axis. And that's exactly what I see. That's exactly what I see. The blue one is a reflection of the purple one. Okay, I don't need the red one. I don't need the black one. I don't need the purple one. I'm only concerned about the blue one. What's happening? The last one is plus 2. The last one is plus 2. So I'm going to take the blue one. Plus 2 will move it up 2 units. And I'm going to show you what it might look like. Moving something up 2 units would mean it will be here. Okay, this will be here. And this will be here. So it'll look more like this. This is my prediction, okay? So let's do it right here. Okay, mx is negative 2 x plus 3. What is it? Plus 2. I think it was plus 2. See, my green curve is my final curve, which is not bad according to my pink line. So your final answer is the green one. Now, I know we are being recorded, and that's a good thing, guys. I will ask you, and I will give you some multiple choice, okay? But I will also ask you in English, can you tell me what this will do? For instance, if I say, let's do one. If I ask you to tell me, what would this do? If I say, this is f of x, this is g of x, what would it do? Now, you can look at your table and tell me this will be a shift, a vertical shift by 4 units. Or you can graph it and look at your picture and describe it in English, which will be the same. Okay, what would this do? This will be a vertical shift by 3 units. So it'll basically go 3 units up. Okay, what will this do? You could say it will first go 3 units to the left and then 2 units down. 3 units to the left, 2 units down. And we're going to graph this and show you that I am not wrong. So let me try this. Let me see what it is. Plus 3 minus 2. Let's do it here. We don't need this anymore. Plus 3 minus 2. Okay, plus 3 does, plus 3 takes it 3 units to the left, and then minus 2 pushes it 2 units down. So I can give you those questions. So again, if you just tell me it'll go left, that'll only give you half points. If you say it'll go left 3 units, then it will go down 2 units. Now, the language that you will use should be consistent with this kind of language, the language that your book is using. They're calling it shift. Some people call it translation. I'll take both. Okay. vertical translation, vertical shifts, both are fine. I think most of you will stick to the language your book uses. Reflection is called reflection. I don't think they say anything else. Vertical stretching, vertical shrinking. I think that's pretty standard. Horizontal. So just a few words, okay? Vertical shifts or translation, I'll accept both. Horizontal shifts or translation, reflection, and vertical horizontal shrinking and stretching. Just 4 or 5 words. Those words you're going to use, and you're going to tell me the number. Is it going to go 2 units up, 3 units down? That's different from going 3 units up and 2 units down. Let's pause there a little bit, guys. Now, it will kick me out in like 3 minutes, but it's actually, we have done enough recording. I'll be here to take your questions. It's a little hard. And why am I saying that? So that you're going to practice a little more. You're going to ask more questions for those reasons. I'm not trying to scare you.
You have a good day, sir.
You too, Jack, and everyone else. Now, if you want to leave, be my guest. No problem. I'm gonna come out and not record anything. I'll hang around here. If people come back, want to ask me questions, that's totally fine. But I'll be here for another 5 minutes or 10 minutes or so till 11. If you don't have any questions, feel free to leave. I don't have any plans on recording other things. Okay, guys, I'm going to jump out. I'm going to jump back in, okay? No more recording. If you have any questions, come back. I'll be back though anyway.